So in this lesson, we're looking at how to find the domain of a function. First of all, we need to know what a domain is. The domain of a function is the set of all real inputs for which the function is real and defined. So basically, we have to get y values, f of x values, that are real and defined. And so we have to limit our inputs to any values of x that will make the y's that come out be real and defined. We can find domain two ways, graphically. You've done that many times in Algebra 1, Algebra 2, whatever. We'll go over it in another unit. And algebraically. This is what we're really focusing on this lesson. So let's think about these two conditions here. How do you get a number that isn't real? Well, numbers that aren't real are imaginary numbers, like complex numbers. They come from trying to take the square root of something that's negative. When is the answer to a math problem not defined? The only thing we're going to look at this point in pre-cal is something is undefined if you try and divide by zero. You divide by zero, you end up with something that's undefined. So let's have a go at some examples. Finding the domain algebraically, what we're going to have to consider is this. The domain of most functions is all real numbers. There's only two things we're looking at that's going to stop the domain being all real numbers at this point. There's other ones that exist, but don't worry about those for now. You cannot have a denominator of zero, because if you have a denominator of zero, you'd be dividing by zero, and that's going to give you a y value that's undefined. And you cannot take the square root of a negative number. So let's have a look at example 1 here. Our function of x equals the square root of 2 minus x. We haven't got any fractions here, so we've got no dividing. We don't have to worry about this one. Dividing by 0 is not a problem. But we do have a square root symbol, and under that square root is sitting our variable x. You only have to worry, look where your x's are. It's only if x's are in any of these places that you have to worry. So we can't take the square root of something that's negative. If the stuff under the square root can't be negative, what can it be? The only x values that we can have are things that would make this not be negative. And if they are not negative, then they must be greater than or equal to 0. You can take the square root of 0. So just add x to both sides, and you get up left with 2 is greater than or equal to x. X is at the sharp end, it's at the pointy end, so your x's are smaller than 2. So here's our domain, drawn on the number line. Here it is in interval notation. Be very careful to include that too. Your answer would be wrong if you put a parentheses there. I've not written that as nicely as I should have done. Please, if you're using a square bracket, make sure it's very clearly a square bracket. Okay, if you want to try this one on your own, then pause your video now, work on it for a couple of minutes, and come back and let's see if you get the answer right. So on this one, we have both a fraction with an x in the denominator, and we have a square root with an x under it. So we've got to look at both of these conditions. The first thing I'm going to look at is this fraction. We cannot divide by 0. That means that this denominator here cannot equal 0. X plus 4 cannot equal 0. How we're going to solve this is we're actually going to exclude when x plus 4 does equal 0. So this is going to give us all real numbers except for x equals negative 4. So that on a number line looks like this. At this point, just looking at this part of the function, the only value we have to exclude is x is negative 4. Everything else is good. Now let's have a look at the square root. It's the second thing we have to consider. We know that the square root of negative 3 minus x, just as in the last example, cannot be negative. If it cannot be negative, then it must be greater than or equal to 0. Which gives us, I'm just adding x to both sides, negative 3 has to be greater than or equal to x. Put that one on a number line and we get, there we go, we get that. Now these two conditions now have to be put together. So draw a number line, put your two numbers on them. Then put these things on. We've got the number 3, which gets a solid blob above it, oops, and the -4 gets a open circle, then this part is no longer valid. Anything from here doesn't count because it's just we're putting these two things together. It's where they overlap. Anything that's on this final domain of the function has to satisfy both this interval here and this one here as well. So our answer is that. Don't forget, if you want to, you can put a union between there, but the union is optional. I haven't even bothered drawing it like that. You can put a little u in there if you want. So our domain here goes from -infinity to -4, and we're just excluding the -4. See here, it ends there and it starts there. We're just excluding -4 itself. Then we go up to -3 included. Okay, this one, try this one on your own now. I'm going to flash up the answer. If you get the answer right, then you can skip the rest of this video and move on to the next video for today. If you don't get the answer right or more help, then you can watch the rest of the video afterwards. So pause your video and work that one now. The answer you should get is this. You can miss out those U's if you want. If you didn't get that, stick with me now. If you did get that, stop this video, move on to the next one. So looking at this, remember, we cannot have a denominator of 0. We cannot have a negative under a square. We can't take the square root of something negative. No square roots. We do have a denominator with x's in. So all we're saying is that this denominator here, where is it? We cannot divide by 0 or our y will be undefined. So all we have to look at is the denominator and say this cannot equal 0. So what we're going to do here is we're actually going to exclude any x values for which it does equal 0. This is quadratic, so let's factor it, use the 0 product rule, and exclude. This one gives us x equals 0, and that one gives us x equals 7. Put those on your number line. Everything else is good apart from just those two values. So in interval notation, you could write it like that without the unions in between them, or you can put those unions in if you want. That's optional. Okay, I hope that went well for you today.